Hey everybody, we're going to continue 3.7 and we're going to do compound interest. I'm going to start by showing you the formula for compound interest. So let's share the screen and here we go. Okay, so the compound interest formula, this is how it works. It is, so here's the formula. A of A is equal to P times 1 plus R over N to the NT. So the P here stands for principal. Principal, that's the guy who's in charge of your school. No, I'm just kidding. The principal means the original amount of money that you conked down. Is you went to the bank originally and you gave them this much money. That's the principal. R is the annual interest rate, but you have to express it as a decimal. So if it's 5%, that would be 0.05, for example. And A, or A of T, is the amount that the account is going to have at the end of T years. Because, so A of 2 would be what's going to be 2 years later. In other words, it's going to be it's going to be there, it's going to be collecting interest, blah, blah, blah. How much is going to be there today? So I'm going to get, and this is what we call compound interest. And N, see there's an N in there, there's a little N in the function. That means it's compounding it N times per year. So if it's compounded monthly, N would equal 12. If it's compounded daily, N would equal 365. If it's compounded quarterly, N would equal 4, and so on and so forth. Anyway, the formula is A of T. A is a function of time. It's equal to P, that's the principal, times 1 plus R over N to the NT power. And this is something you would just plug into the calculator and just crunch out your answer. Now, what if you get interest compounded, not just daily and not just, what if you get interest like every second, So that's called continuous, compounded continuously. And A of T is equal to P times E to the RT. Looks like PERT, which I think used to be a shampoo. So A is equal to P times E to the RT. And that's if the interest is coming every split second, the constant flow of interest every split second. So if you're using the formula to find what the account is going to be worth in the future, and then this is called the future value. And if you want to know what you need to deposit today to have a certain value, a certain amount of money in the future, then A of T is called the present value. In other words, I want to know in other words, I want to have $1,000 in 5 years from now. So how much do I have to invest now? So maybe I only need to invest 800 now, and then in or whatever amount, I don't know how much, then it's going to be 1,000 in a couple of years. So future value, present value. So present value is what you need. Is the present value is what you need to invest in order to get a certain target amount. And people do that, by the way. They're thinking, hey, I'm going to need this much money by this time, so I'm going to have to invest this much, and they crunch it all out. So that's this I like this because this is the world. This is very practical. This is the world. Now, there's one part of this definition which I want to explain. I kind of glossed over it, but I want to really, really explain it carefully. Here it says t is greater than 0 in the future value case, and t is less than 0. Time is less than 0, negative time. What does that mean? So when we want to find the future value, we're saying right now is ground zero, and the future that's going to be when t is going to be 2 years later, so it's going to be t is going to be 2. But here, what we're doing, if we want to know in 2 years, I want to have $1,000. What do I need to invest now? So we call 2 years from now, we call that ground zero. And now, right today is -2. T would be -2 because it's going to be 0. Like my target date is going to be 0. So now it's going to be negative, whatever my target. If my target date is 5 years away, so today would be -5. And then when you find A of -t, that's going to give you what's called the present value. And that's the value that you need to the amount that you need to get your target at that desired future date. So that's a pretty important thing to realize, and because t is less than 0, huh? But that's that's okay. That's okay. Now let's look at something else. Continuous income stream. So suppose money can earn interest at an annual interest rate of R, compounded continuously. Now f of t is we want that to be a continuous income function, and it's dollars per year that applies between the year 0 and the year t. So f of t is money is like flowing in, but according to this function. So the present value of that income stream is given by PV. PV stands for present value. That's not P times V, but it's PV, present value. Is equal to the integral from 0 to t, and t is that the year t. Now, the year t is like 2025. We say that today is 0, so 2025 would be t equals 3. Anyway, so it's from integral from 0 to that year of f of t, that's the function that the money's flowing in on, times e to the minus rt dt. And that's the present value. The future value, that you get just from the regular compound interest formula, that future value is equal to the present value times e to the rt. So that's how it works. So future value is present value times e to the rt, which is basically the compound interest formula. Let's look at some examples here. Let's see if we can get something going here. We got some nice examples. So example 3, you have the opportunity to buy a business that will earn $75,000 per year continuously over the next 8 years. Money can earn 2.8% per year compounded continuously. Is this business worth a purchase price of $630,000? In other words, the seller is asking for $630,000, and is it worth it, given how much you're going to earn and the next 8 years and so on and so forth. So let's see. So first, you have to make some assumptions just to simplify things. We're going to assume that this 75,000 is going to stay constant. We're also going to assume the interest rate is going to stay constant. Interest rates change all the time, but for simplicity's sake, we're going to assume it's going to be 2.8 the whole time, and we're going to assume that the 75,000 per year is coming in continuously, like a faucet dripping dollars into the business. And now, in reality, neither one of these may be true, but we're going to have to assume that because money doesn't necessarily flow in equal amounts every minute. It comes in ebbs and flows. You know what I'm saying? But to make it simple, we're gonna assume that. Okay, so the present value of the 630 is, well, 630. This is one investment where we put our 630 in the bank and let it sit there. Now, to find the present value of the business, we think of it as an income stream. The function f of t is the constant $75,000 per year. So f of t is equal to 75,000. The interest rate is 2.8%, which as a decimal is 0.028. And the term, the amount of time we're talking about is 8 years, because it said over here 8 years. It said right there 8 years. So t equals 8. So present value is going to equal to the integral from 0 to 8, because that's 0 to t, times f of t, which is in our case just 75,000, times e to the negative 0.028 t dt. And that, if you crunch that out, that's going to be approximately $672,511.66. So the present value of the business is around 672,000, which is actually more than they're asking for. They're asking for 630,000. So paying 630 for something that's really worth 672. I mean, that's a good deal. Now, of course, nothing's guaranteed, and that's why you're paying less than the calculated value, because nothing's guaranteed. Things could change, things get better, they could get worse, and so on and so forth. I just want to show. I just want to go through how we got this integral. This part right here. I just want to show how we got that part right there. Let's make this. Let's highlight this. I'll make it yellow so we can see. I'll make this whole thing. By making it yellow. Uh, I wanted to just make the whole line yellow, but it's breaking it up for some reason. Okay, so now I'm going to switch cameras and get some paper here. So let's do this right now. All right, so here it is. So first thing I'm going to do is I'm going to bring the 75,000 out of the integral. So this is equal to 75,000 times the integral from 0 to 8 of e to the negative 0.028 t dt. And I'm going to do a little substitution here. I'm going to let u equal negative 0.028 t, which means du is equal to negative 0.028 dt, which means that negative 1 over 0.028 du is equal to dt. That means that the dt over here is going to be replaced with the negative 1 over 0.28 du. What happens now is that my integral is going to be, this is going to equal 75,000 times the integral. Now, I'm going to leave this blank. Instead of 0 and 8, I'm going to leave it blank for now, because I'm going to back substitute later. But this is going to be e to the u times du divided by negative 0.028. And this is just equal to negative 75,000 over 0.028 times e to the u, but I'm going to put the t back. E to the negative 0.028 t, and this is going to be evaluated between 0 and 8. So this is going to equal now to negative 75,000 over 0.028 times e to the negative 0.028 times 8. Because 8 was the value of t, minus negative 75,000 over 0.028 times e to the negative 0.028 times 0. And of course, that's just e to the 0, which is 1. And if you crunch all this out, you're going to get 672,000. $672,000, and so that's our answer, and that's how we do that integral. Okay, but that was loads of fun. Let's look at another example. So let's go back. I'm going to stop. I'm going to share the screen again, and I'm going to put my camera back on me. Okay, here we go. So let's look at another problem here. Okay, a company is considering purchasing new machine for its production floor. Company is looking at a new machine for its production floor. The machine costs $65,000. The company estimates that the additional income will be a constant 7,000 for the first year, then will increase by 800 each year after that. So it's going to be bringing it to a real cash cow over here. In order to buy the machine, the company needs to be convinced that it will pay for itself by the end of 8 years with this additional income. Now, the money can earn 1.7% interest per year, compounded continuously, should the company buy the machine. So again, we're going to assume that the income is going to come in continuously over the 8 years. And we're going to assume that the interest rates are going to stay the same and blah, blah, blah. But interest rates could go up, they can go down, anything can happen. No one has a crystal ball. Okay, so we want to know the present value of the machine, and then we're going to compare that to the $65,000 price tag that they're asking. So T is going to be the time in years since the purchase of the machine. The income from the machine is different depending on time. Meaning it varies. The income varies because every year it increases. So here's how it's going to work. So from t equals 0 to t equals 1, meaning the first year, the income is going to be 7,000 per year. From t equals 1 to t equals 8, it's going to increase by 800 each year. So the income flow function, let's look at this, is going to be 7,000 because that's our base price. That's what we're starting at. Plus I'm adding 800 every year. The first year I didn't add any 800s. That's why it's t minus 1. But the second year I've added an 800, third year another 800, and so forth. And of course, if I simplify this and combine like terms, this becomes 6,200 plus 800t. So 800 times t, 7,000 minus 800 is 6,200. Okay. Now to find the present value, we're going to have to divide the integral into two pieces, one for each of the functions. So the present value is going to be the integral from 0 to 1 of that base 7,000 times e to the negative 0.00017 t. Now, where did that point zero negative where did the 0.017, where did that number come from? That came from the interest rate, which they told us was 1.7% per year, and we're writing it as a decimal. And we make it negative also. So then we have to add on the integral, this f of t integral, which is 6,200 plus 800t, and times e to the negative 0.017t dt. And if we crunch this out, we're going to get 70,000, which is greater than what they're charging. They're asking 60 something thousand. So the company should buy the machine. But let's work through this. Let's work through this integral together. So here we go. I'm copying it down, and I'm going to switch cameras. So PV equals the integral from 0 to 1 of that base 7,000 times e to the negative 0. Okay, oh, did I? Okay, here's the integral. I wrote it down. So the integral, so here I'm gonna, for this one here, I'm gonna take out the 7,000. The integral from 0 to 1 of e to the negative 0.017 d dt. And I could do the u thing, but basically all is going to happen is I'm going to wind up dividing by the 0.17. So this is going to be 7,000 over negative 0.017 times e to the negative 0.017 evaluated between 0 and 1. And that's going to be equal to negative 7,000 over 0.017 times, oh, I left that little t, sorry. So times e to the negative 0.017 minus e to the 0. That's the first integral. Now the second integral is going to be, I could take out, I'm not going to bother. This is going to be 6,200 t. The integral of 6,200 is 6,200 t, and this is going to be 800 t is going to be 400 t squared. Now, why is it 400? How did the 800 become a 400? Because the integral of t is, ooh, wait a second. Uh, oh, not so simple. I'm sorry. I didn't even notice this. Hold on one second. Hold on one second. Sorry, everybody. I was looking at the 6200. I didn't even notice that. Hey, this changes everything drastically because this is going to become integration by parts because it's going to be the integral. I'm going to break this up into two integrals. This is going to be plus the integral from 1 to 8 of 6,200 e to the negative 0.017 t dt plus the integral from 1 to 8 of 800 t times e to the negative 0.017 t. And so for this one here, this one here is going to be very similar to this. It's going to be basically the same as, it's almost the same as this one here. So it's going to be, this is going to be negative 6,200. I'm really kind of following the same template over 0.017 times e to the negative 0.017 times 8 minus e to the 0. That's this guy right here. Now the last integral, I'm going to have to do integration by parts. So I'm going to pull out the 18, the 800, I mean. So it's plus 800, the integral from 1 to 8 of t e to the negative 0.017 t dt. And I'm going to let u equal t, and dv is going to be e to the negative 0.017 t dt. V is equal to e to the negative 0.017 t over negative 0.017, and du is going to equal dt. So this is going to be equal to uv, which is t, times e to the negative 0.017 t over negative 0.017, and then minus the integral of v du. So that's going to become a plus the integral of 1 over 0.017, I should say. Maybe write that better. 0.017. Wow, try it again. Plus 1 over 0.017. Now the reason it became a plus instead of a minus because the formula has a minus and the two minuses canceled, times the integral of e to the negative 0.17 t dt. And this integral, so this one here, this is not an integral at all, and that's from 0 to 8. This has to be evaluated from 1 to 8. This is evaluated from 1 to 8. And now finally, we have this integral here is going to be minus 1 over 0.017 squared times e to the negative 0.17 t evaluated between 1 and 8. So I'm not going to have room to write everything. It's going to be this part here. And I'm going to add, so to this part here, I'm going to add t times e to the negative, 8 e to negative 0.017 times 8 over negative 0.017. Now I'm going to say minus, but the minus is going to cancel out that negative, so it's going to be plus 1 times e to the negative 0.017 over negative 0.017. That's this part here. And then minus 1 over 0.017 squared times e to the negative 0.17 times 8. And then minus, so it can become plus 1 over 0.017 squared times e to the negative 0.1017 times 1. And so this is what I'm adding on. See how much fun this is? So basically, but all this stuff here, now it all could be crunched out of the calculator. I mean, it looks hideous, but it just could all be crunched out with a calculator. And so is this whole thing here, plus this, plus that, minus this, plus that, and so on and so forth. And that's what we, that is our story, and we're sticking to it. That is our, I just want to look at one thing here. What is that? Did I miss a minus anywhere? Minus, plus. Just give me 1 second. There's something that's not making sense here. This is 8 minus this. That right there. So it's 8. Right. And minus Negative. Oh, that should be a plus right there. But because the negatives, the two negatives that canceled. Now it makes more sense. That was bothering me. Now it makes more sense. And there you go. So this. So add up all that stuff, and if you add up all that stuff, you're gonna get approximately um you're gonna get approximately 70,000, and I believe it was 166 dollars. Just, but again, this is something that can be crunched out on a calculator, and that is my story, and I'm sticking to it. And that concludes 3.7 part two. Hope you enjoyed it as much as I did, and we're going to see you guys next time on the next video. Bye.